Okay, in this video I am going to talk about a Maxwell equation in thermodynamics, and one is the complicated things that how to remember the Maxwell equation, because it is so complicated. So first of all, I am going to tell you how to write the Maxwell equation, and then I will derive this equation in a easy step. So first of all, what is the Maxwell equation? Maxwell equation is the equations by which we can determine the state of a homogeneous thermodynamic system if mass and any of the two quantities is known, that is ST, PVU, and entropy, temperature, pressure, volume and internal energy. If mass and any of the two of these quantities is known, then we can determine the state of the homogeneous thermodynamic system. Okay, and the Maxwell equation are generally is the relation between S, T, P and V, and there are four Maxwell equations. So first I will write the Maxwell equation, then I am going for derivation. So in Maxwell equation you have to learn three steps. First, that always ST is equal to PV, ST is equal to PV by cross multiplication. Okay, so STPV, we can write this TSPV first. In cross multiplication, this is ST, TS, whatever, and this is PV. So first we can write del T by del V is equal to del P by del S. Okay, the first. Second, PV should be remain here, and we can interchange T and S. By interchanging T and S, we can write del S by del V is equal to del P by del T. There are two Maxwell equations. For writing third, we write the same one, but interchanging P and V. First, I am interchanging T and S, and now in this we interchange P and V. So this is del T by del P is equal to del V by del S. For 4, we write 2 by interchanging P and V. This is del S by del V is equal to del, this is, we have to interchange P and V. So we write here P, S should be same, del V by del T. Okay. These are the four Maxwell equations. Once again, I will repeat you. First, we have to write TSPV, TSPV, and then we interchange T and S. This is the second. And after writing two equations, we have to write again one by interchanging P and V. Okay. For fourth, we again write equation 2 by interchanging P and V. And these are the four Maxwell equations. Now, second step, that variable on another side become constant. What does it mean? That here V is the variable, here S is the variable. So S is constant here, V is constant here. Okay. Similarly, V is variable and here T is variable. Then V is constant, T is constant. Variable on other side become constant, variable on other side become constant. Variable on other side become constant, variable on other side become constant. Okay. These are the two steps. Third, if T and V are in same side, then negative. Okay. So we see in first equation, this T and V are in same side and this is in same side. So this is minus, this is minus. Okay. So these are the four Maxwell equations. Now I am going for derivation. First we write the first law of thermodynamics, that is dq is equal to du plus pdv, and the second law of thermodynamics in terms of entropy is t ds, and after combining these two equations we can write t ds is equal to du plus p dv. Also it can be written as du is equal to t ds minus p dv. This is the equation number 1. Okay, it's clear. Now we can introduce the two independent variable x and y as u is xy, s is equal to sxy, and v is equal to vxy. Clear? And if we differentiate these three quantities, then we can write du is equal to del u by del x dx plus del u by del y dy, and similarly for s, ds is equal to del s by del x dx plus del s by del y dy, and for v, this is dv is equal to del v by del x dx plus del v by del y dy. Okay, now we put this value in equation 1. So for du we write this. So this is del u by del x dx plus del u by del y dy, and this is equal to t, and ds is this. So del s by del x dx plus del s by del y dy, bracket close, minus p, and dv is this, del v by del x dx plus del v by del y dy. Clear? So if we can write, if you remove this bracket, then t is multiplied by these terms and these terms. So this is t into this, and this is t into this. If you remove this bracket, this is minus p, and this is minus p. Okay. So now here is the terms of with coefficient dx, and here is the dx. So we can write del u by del x dx plus del u by del y dy is equal to t del s by del x, and this is minus p del v by del x, and dx is common. Okay, in these two terms dx is common. Similarly for these two terms dy is common, so we can write plus t del s by del y minus p del v by del y. Is dy common. In this equation, if we compare the coefficient of dx and dy, here the coefficient of dx is del v by del x. Here the del, sorry, not v, this is the u, it's basically the internal energy. So del u by del x is equal to, here is the coefficient of dx is this, t del s by del x minus p del v by del x. This is equation number 2. Similarly, the coefficient of dy in right hand side is del u by del y, and coefficient of dy in sorry, this is left hand and this is right hand, this is td, t del s del y minus p del y v. Clear? This is equation number 3. Now we differentiate this equation with respect to y. If the differentiation is with respect to x, then we differentiate this with respect to y, and if this is the differentiation with respect to y already, then we differentiate this with respect to x. So differentiating equation 2 with respect to x, sorry, y, and differentiating equation 3 with respect to x, then we get, this is the del 2 u by del x del y is equal to t del 2 s by del x del y plus del t del y del s del x. This is the differentiation of these terms by taking apart. For this, minus p del 2v by del x del y minus del p by del y del v by del x, equation number 4. Similarly, the differentiation of equation 3 with respect to x is written as del 2u by del y del x is equal to, this is t del 2s by del y del x plus del t by del x del s by del y minus p del 2 v by del y del x minus del p by del x del v by del y, equation 5. Since the u, s and v are the perfect differentiation, u, s and v are the perfect differentiation, so del 2u by del x del y is equal to del 2u by del y del x. Similarly, del 2s by del x del y is equal to del 2s by del y del x, and for v, del 2v by del x del y is equal to del 2v by del y del x. Okay, because it is the exact differentiation. Now, in these two equations, equation number 4 and 5, these two terms are equal. So this term should be equal to this, and if we write this is equal to this, then these two terms are cancelled out. Then what will be remain here is the del yt del xs minus, this is minus del y p and del x v, and this is equal to del x t del y s minus del x p del y v, and this equation is known as the Maxwell general equation. And from this Maxwell general equation, we can write the 4 Maxwell equation by substituting x is equal to s t s t. For our convenient, this is st st, and y is v p p. If we write x is equal to s and y is v, then this will become the first Maxwell equation. Similarly, this is for second Maxwell equation, this is for third Maxwell equation, this is for fourth Maxwell equation. So for first Maxwell equation, we write here is the general Maxwell equation. If we write s is equal to x and y is equal to v, first s is equal to x and v is equal to y, then this is del s by del x with respect to x is equal to 0, del s by del y, here y means v is constant, then this is equal to, sorry, this is 1 and this is equal to 0. S with respect to x is 1 and with respect to y is 0. Similarly, del v by del y is equal to 1 and del v by del x is equal to 0. So del s by del y is 0, del v by del x is 0. If we put in this general equation, del s by del y is here, this term is equal to 0, del v by del x is here, this term is equal to 0, and del s by del x, this is equal to 1, and del v by del x, del v by del y is equal to 1. So these two terms are equal to 0, this is 1, this is 1, and then what will remain? This is del t by del y is equal to minus del p by del x, and y is basically v, so we write here v, and x is basically s, so we write here s, and t is equal to s, p into t into s, ts is equal to pv, and t and v are in same sign, then this is equal to negative. And if the differentiation of t with respect to v, then s is constant, because here s is constant and here v is constant, so this is p. This is the Maxwell first equation. Okay. Similarly, we can write s is equal to x is equal to t for the second. So S is T and V is equal to Y, then we write T is equal to Y. Then what will be the differentiation? Del T by del X is equal to 1, del T by del Y is equal to 0, and del P by del Y is equal to 1, del P by del X is equal to 0. So if we put this 4 value in Maxwell general equation, del T by del Y is 0, then this terms is equal to 0, del P by del X is 0, del P by del X, del T by del Y 0, okay, and del P by del X, this is equal to 0. Okay, is not correct. We have to write T is equal to X and V is equal to Y basically. So this is V is equal to Y. Okay, so this terms is equal to 0, del V by del X, this is equal to 0, and here del T by del X is 1, this term is 1, del V by del Y is 1. Then what will remain here? In these terms, this is equal to 0, 0, and here is del S by del Y minus del P by del X. And if we write this, del S by del Y is equal to del P by del X, and here Y is V, then this is del S by del V is equal to del P by del T, X is T. So this is the second Maxwell equation. So here T is constant variable, so T is constant here and V is constant here. This is the second Maxwell equation. Now for third Maxwell equation, we write S is equal to X and T is equal to Y. So we write here del S by del X is 1, del S by del Y is equal to 0, and del P by del Y is 1, del P by del X is 0. So by putting this 4 value in this Maxwell general equation, del S by del Y is 0, del P by del X is 0, del S by del X is 1, del P by del Y is 1. Then in this term, in this side, this is equal to 0, and in this side, del T by del Y minus del V by del X. And if we take this term in this side, then this is equal. So we can write del T by del Y, Y is basically P, is equal to del V, and X is basically S. So this is third Maxwell equation, and we put the constant as the S and P, okay, according to this. Now one more is the last, fourth Maxwell equation. We have to write T is equal to X and P is equal to Y as the same. Okay, so this is T, and this is P is same here. So del T by del Y, this is equal to 0, del P by del X, this is equal to 0, del T by del X is 1, this is 1, del P by del Y is 1, this is 1. Then what will remain here? Minus del P by del Y is equal to del S by, is the mistake something here, del T del Y is 0, del P del Y 1, del T del X 1, this is 1. So here is the del V by del X basically. Here is, and this is 1, and this is minus del V by del X is equal to del S by del Y. Okay, and if we write this term is del S by del Y, Y means P is equal to, this is minus del V by del X for T. Okay, so this is the fourth Maxwell equation. Here T and this is P. T and V are again in same side, then this is negative. So we can check this four Maxwell equation: T S P V, H T P V, T S P V, H T P V, and T and V in first is in same side, and this is negative. T and V in not in same side, so T and V is not in same side. T and V is in same side, and this. So these Maxwell equations are correct. Okay, thank you.